Hi friends, welcome to Unit 3. This unit talks about quadrilaterals. Before we get into quadrilaterals specifically though, we're going to be looking at polygons in the general sense, and that's what this lesson really focuses on, is solving, finding relationships within the polygons, and then also within the different angle measurements. So this particular section, we really have to have a solid understanding on what a polygon is. A polygon is a closed plane figure with the following properties. Closed means that it has no holes in it. So if you think of something that it has a shape that's flat, it's two-dimensional, that has a hole in it or it's not connected, then that would be open. It is formed by 3 or more line segments called sides. Each side intersects exactly 2 sides, one at each endpoint, so that no 2 sides with a common endpoint are collinear. So essentially that means you can't draw a line out, a line segment out a little bit, and then draw it out a little bit more, and say that that's 2 different sides. There are different parts of a polygon. So let's talk about the different parts here. So segment AE is called a side. So this little dash there is pointing towards that side. And then we have a diagonal. So B to D here is called a diagonal. And then C is a point, but in this particular polygon, we actually call it a vertex because it's a vertex between 2 line segments. So we call polygon A, B, C, D, E, so we're naming it by all of its vertices. So it's named, oh, forgot that I need to pull that down. Named using its vertices. Usually we write them also in alphabetical order, so notice that it's A, B, C, D, E, not a different order. And this is called a pentagon. And we have special names for a lot of the sided figures that we have for 2-dimensional shapes. So what I would like for you to do, if you haven't already, go ahead and pause the video and then fill in what you think for these. Some of these you'll know because you've seen or heard of before. And then we'll talk about the number of diagonals that each of them have shortly. So pause the video if you haven't, and then give it your best shot. And now let's go ahead and fill them in. So the name of a polygon with 3 sides is called a triangle. With 4 sides, it's called a quadrilateral. So I've kind of skipped over a number of diagonals for a triangle because I wanted to create a quadrilateral to kind of showcase off what a diagonal looks like. So this is a 4-sided figure, which is all that a quadrilateral needs to have. It just needs to have 4 sides. So the diagonals have to be uniquely independent from one another. So this diagonal that goes from here to here is independent of this diagonal that goes from there to there. So a quadrilateral, in fact, has 2 diagonals. When I make a triangle, all of the vertices are connected, so there aren't any additional diagonals that we could draw. So there's 0 diagonals for a triangle. The name of a 5-sided polygon is called a pentagon, which I shared from earlier. And that has 5 diagonals. A 6-sided shape is a hexagon. And that has 9 diagonals. So far, talking about a pattern, so to get from 0 to 2, I had to add 2. To get from 2 to 5, I had to add 3. To get from 5 to 9, I had to add 4. To get from 9 to the next one, I'm going to have to add 5. A 7-sided shape has 2 names. It's called a septagon, and it's also called a heptagon. You will see both in this course. So 9 plus 5 is 14. So this next one, 8-sided shape, is an octagon. That is 20 diagonals. A 9-sided shape is a nonagon. 27 diagonals. A 10-sided shape is a decagon. Similar to a decade is 10 years. 35 diagonals. An 11-sided shape is an undecagon. I emphasized because now we're getting into a naming system that is pretty common in languages other than English, where to name something with numbers, what they do is they usually do like 1 and 10. Way to think about it is French un, or uno, Spanish uno, and then decagon. Deca is 10, gon is sided shape. So this is 1 and 10 sided shape, and this has 44 diagonals. Then a 12 is dodecagon, or duo, shortened, decagon, and that has 54 diagonals. Now we get to this last one. It says n. So anything that is above a 12-sided shape. There are some names for some of these. However, at that point, to simplify, we just call it an n-gon, where n is the number of sides it has. So I could say that something is a 13-gon or a 27-gon as an example. And the diagonals depends upon how many, again, how many sort of sides it has. So we'll be talking about later about what we can use to determine that. So then, what you have here on this next page is drawing out all of the possible diagonals, and then we'll be jumping into then the next part where it talks about naming them the name of the triangles. So let's go ahead and draw the diagonals. So for the triangle, we can't draw any. So this triangle has one triangle that's inside. For here, what I'm going to do is draw a diagonal from this part of the quadrilateral to this other part. What that does is that gives me 2 triangles. With a pentagon, if I start from here and I go to there, and I go to there, then I have 1, 2, 3 triangles. And then for the hexagon, there's 1, 2, 3, 4. So 1, 2, 3, 4. So in the next video, I'll talk about what that means in terms of decomposing these, which means break apart or make smaller, these shapes, and what that means with the triangles. Have a wonderful day.